Welcome, students. Today we're going to be talking about graphing rational functions. In this video, we're going to speak very generally. So we've got this example equation here. Now, notice that it doesn't really show a lot, and we've got these dots indicating this equation can go on. We're going to be talking about how to graph arbitrarily large rational functions. So n and m, these exponents, could be of any size, and the ... just indicates all the rest that there could be. However, just knowing a bit about these first terms actually tells us a lot about how this is going to be graphed. So when n is the largest exponent, and so n is your largest exponent in the numerator. M is going to represent the largest exponent in the denominator. Okay, and we would assume that after that ... everything's in descending order. Okay, so let's talk about asymptotes. Those lines that our graph is going to get closer and closer to without really touching. Okay, so the vertical asymptotes are going to be found where x equals k. So that is if the denominator is 0. So any number where it makes the denominator be a 0. So we would factor out our denominator and find out any number x equals k that makes that 0. Okay, there is one caveat to that, and the numerator isn't 0. Okay, so if the denominator and the numerator are 0 at the exact same place, that does not cause a vertical asymptote, but it'll create something else that we'll talk about in just a moment. Okay, next we've got a whole bunch of rules about n and m. Remember, n is the biggest of the numerator, m is of the denominator. So if the degree of the numerator is less than the degree of the denominator, the x-axis is going to form a horizontal asymptote. If the degree of the numerator is the same as the degree of the denominator, then a over b, to figure out what a over b is, right there. Okay, so the coefficient of the leading coefficient of the numerator and the leading coefficient of the denominator. We divide those, and that will become the horizontal asymptote. Y is equal to a over b. If the degree of the numerator is greater than the degree of the denominator, there is not going to be any horizontal asymptote. However, that does cause a unique situation. When the degree of the numerator is greater than the degree of the denominator, it creates an oblique asymptote. These are also called slant asymptotes. These asymptotes can be found by long dividing the numerator and the denominator. The equation of the quotient without the remainder is what creates that asymptote. So you will have an asymptote that, rather than being just straight horizontal or straight vertical, could actually be a diagonal line. And the way we'll find what that line is by using our long division of the numerator from the denominator, and then whatever equation is left, excluding the remainder, that's what creates the slant asymptote. Next, we're going to have holes. Holes are where the denominator and the numerator are 0 at the same place. So when x will create a 0 both in the numerator and the denominator at the same time, that creates a hole. So here are the steps we are going to follow. First thing we will do with any of our equations, we're going to find the intercepts. After we've found the intercepts, we're going to find the vertical asymptotes, find the holes, find the horizontal asymptote. Okay, or I should also say the slant asymptote at that point. Then the vertical asymptotes are going to divide our graph into regions. So we've got left of each asymptote and right of each asymptote. So in each region, we want to graph at least 2 points. I would actually recommend we'll do about 3. And those points will tell us whether the graph will be above or below the horizontal or slant asymptote. They'll give us a good idea of kind of where to draw our lines. So that's why we want those points. And the more points you find, the better your graph is going to look. Okay. One extra thing I would add to this, the first step I would do, if I can see that it's possible, is factor. Okay, factor these equations whenever it is possible. All right, so let's get started into a few examples. So example 1, I don't see much to factor there, so we're going to go ahead and leave it as it is. First thing we're going to do is find the intercepts. So I'm going to start with my x-intercept. And in fact, let's go ahead and zoom in here. So for my x-intercept, the way we find that, and it talked about it up here, the way you find an x-intercept is whenever the y-axis is going to equal 0. So we find the x-intercepts by setting the numerator equal to 0. Okay? Because remember, if the numerator is 0, it doesn't matter what's happening in the denominator, it equals 0. Okay, so for the x-intercept, y has to be 0. When would the y equal 0? If the numerator is a 0. And that's why we do it. So here, my numerator is a 3x plus 6. So I'm going to go ahead and put in 3x plus 6, and I want to know where that equals 0. Well, if we minus the 6 from both sides, and then we divide by a 3, we get negative 6/3, which is negative 2. So that is going to be my x-intercept. All right, so that would be a point where x is negative 2 and a y is a 0. All right, and there is our x-intercept. So next, let's find the y-intercept. The y-intercept is going to occur when x is a 0. So notice this point. The x-intercept happens where the y equals 0. We find the y-intercept where the x is equal to 0. So I'm just going to take the equation we had up there and change my x's to 0. So that would be 3 times a 0 plus 6 all over 0 minus 1, which gives us a 6 over negative 1, negative 6. So when x is a 0, y equals a negative 6. And there is our y-intercept for that problem. So now I'm just going to go ahead and graph those two. Okay, so we know at negative 2, 0, and we know 0, negative 6. Great. So now we've got our two intercepts. Let's go ahead and now find the vertical asymptotes. All right, so a vertical asymptote happens wherever the denominator is equal to 0. So I want to know when x minus 1 when that equals 0. I'm just taking my denominator, finding where it equals 0. So after we add a 1 to both sides, we know this happens at x equals 1. That equation is well, that's weird. Okay. All right, and that right there, x equals 1, that's where our vertical asymptote is. So I'm going to go ahead and this dotted line that is perfectly drawn is going to be our vertical asymptote. Okay, so the next would be the horizontal asymptote. And the horizontal asymptote, or the slant asymptote, remember is all about the degree of the numerator and the denominator. So this is an x to the power of 1, that's an x to the power of 1. So n is equal to an m. So if we go back to our notes up here, we see that if n equals m, that means the line y is equal to a over b will be the horizontal asymptote. That's how we find a and b. So I'm going to have y is equal to my a over my b. In this problem, we had a 3 for a 1 for b. So it's just at y is equal to 3. All right, so that's going to be my horizontal asymptote is right where y equals 3. Okay, so after we've got our asymptotes, now we're going to search for any holes. A hole would be where the numerator and denominator both equal 0 at the same place. Well, we already know the numerator, it equals 0 at -2. The denominator equals 0 at a 1. They never equal 0 at the same place. So, holes, there are none. Okay, after holes, now we are ready to start graphing this. Now, one thing I am going to add to this is I want more points to draw my graph well. I've got these two over here on the left of my line. Remember, these vertical asymptotes divide it into sections. I've got these two, so I want one more there. Then I'm going to want about 3 over here to the right of that. So I'm going to quickly just make an XY table of values that I could put in. So for the left side of that, I'll use a -8. For the right side, a 2.5, a 4, and a 10. It doesn't matter which numbers you pick. And largely I picked these numbers out of convenience. I know the numbers work out pretty. But if you just type these into a calculator, sure, you'll get some decimals sometimes, and it won't be perfectly clear exactly where to put that dot. You won't always be able to put it directly on a line, but that's okay. So long as you get it approximately, that'll be good. So if we put -8 in for x into that equation, we will get 2. If we input 2.5, we get a 9. Input a 4, we get a 6. If we input 10, we get 4. So now with those extra points that we have, we can put at -8. That would be up at 2. At 2.5, we would be all the way up at 9. At 4, we would be up at 6. And at 10, we would be at 4. And now that I've got my 3 points everywhere, just going to do my best to draw a curve that represents what those are doing. Okay, also draw my arrows on there. And hopefully not move graphs. Okay, and there it is, a perfectly drawn graph. Sure, it looks ugly, but it's accurate. Okay, so let's move on to example 2. Once again, let's begin this with our x-intercept. The x-intercept we find by figuring out where the numerator would be equal to 0. Well, that can never happen. So we do not have any x-intercepts. After that, let's go ahead and find the y-intercept. The y-intercept is where we're just going to change all of our x's to a 0 to find that point. So when we have 9 over 0 squared minus 9, give me 9 over negative 9, which is a 1. So when the x's are zeros, the y is 1. And we have the y-intercept. Now that we've got that, let's talk about the vertical asymptote. Okay, so our vertical asymptote, we find this by setting the denominator equal to 0. Now, this is where my suggestion from before comes into play. I wish I had started this off by factoring. This is a difference of squares, so I know that 3 squared is what gives a 9. So this becomes x minus 3 and x plus 3. Okay, if you're not sure how I did that, Google difference of squares. So now, to find my vertical asymptote, I want to know when that denominator equals a 0. Well, it's got 2 places it could equal a 0. If we put in a 3, 3 minus 3 would equal 0. And if we put in a negative 3, negative 3 plus 3 would equal 0. So we have 2 vertical asymptotes at x equals 3 and at x equals negative 3. So we can go down to our graph and go ahead and draw those in. So where x equals negative 3 and where x equals 3. Okay, so now that we've got a vertical asymptote, let's look at the degrees of the x's. Notice the denominator has a degree of 2. The numerator does not even have a degree. It has a degree of 0. So the denominator would be greater. So as we talk about horizontal asymptotes or slant, what we do have is that the numerator has a lower than the denominator. And in those situations, the x-axis is the asymptote. Okay, so because my lines won't show up well there, let's lower that thickness. But I'm just going to draw little highlights there to say that is my horizontal asymptote. Okay, now that we found our horizontal asymptote, we want to think about any holes. Problem is our numerator, which is just 9, can never equal 0, whereas a hole occurs when x creates a 0 in the numerator and the denominator. So as far as holes go, there are none. Slant would require the numerator to have a higher degree. We also have no slant. So now we're ready to start finding some extra points so that we can graph. We've got our asymptotes. We've got 1 point on there. So we just need a few more. So what we're going to do, and remember, we want about 3 in each of our sections. So I'm going to start doing this. We've got -10, and when x is a -10, that'll give us approximately a 0.1. Many of these are rounded, so this time there weren't as many pretty numbers coming out, but we can make that work. So -4 will give us about a 1.3. So there are the first 3, and I want to use those to put into the graph. So at -10, I should be at about a 0.1. That's going to be just barely above the line. At a -6, we should be at about a 0.3, still not very much above that line. And then at -4, we would be up at 1.3. And so we can kind of see what's going to happen in this quadrant, where it's really close, but then it'll shoot up and get closer and closer to that asymptote without ever touching. Okay? All right, so now let's figure out what's happening in the middle there. We do have 1 point, so let's just get 2 more. So up here, let's do -2 and 2, and both times I got a -1.8. Okay, so at -2, we're at -1.8, and at +2, we're at -1.8. And the fact that I crossed my horizontal makes me think my y-intercept, something went wrong there. And sure enough, 9 divided by -9 should have given me a -1. So we will go ahead and erase that. Okay, and so I now see that that's what that line is going to do. So just a few more. Let's do 4, 6, and 10. So at 4 we get a 1.3. At 6 we get a 0.3. And at 10, a 0.1. So at 4, let's draw that 1.3. 6 was at 0.3. And 10 was at a 0.1. All right, and there is, and there's our graph. All right, now let's start this one off the right way. Let's actually factor it to begin with. Once again, the top is going to be a difference of squares, so that's going to become x minus 2, x plus 2. Down here, they've got a common factor of x, so we can pull out an x, and we will get x minus a 4. All right, so now that we are fully factored, and we know that that's our equation, let's start with the x-intercept, which is going to happen where the numerator is equal to 0. So when an x minus 2 and an x plus a 2 is equal to 0, well, that should happen in two places. When x is equal to a positive 2 and when x is equal to a negative 2. That yields 2 points. So when x is 2, y is 0. When x is negative 2, y is also 0. There's our x-intercept, and we can go ahead and put those 2 dots on there. Next, we want the y-intercept. So the y-intercept, we rewrite our equation, but we change all those x's into zeros. So we'd have 0 squared minus 4 all over 0 minus, or 0 squared minus 4 times a 0. Well, that's going to give me a negative 4 over 0, but we cannot divide by 0, so this is just none. So there will be no y-intercept here. Okay, next we want to find our vertical asymptotes. Vertical asymptotes are going to be found where the denominator is 0. So when x times x minus 4, when that is equal to a 0. So for this, the x, what makes it a 0? Well, when x is 0. In parentheses, when x is equal to a positive 4. And we found it. There are the two vertical asymptotes. When x is 0 and when x is a positive 4. So let's go ahead and get those in there. So here, when x is a 0 and when x is 4. Okay, so now for horizontal asymptotes or slant, we want to check the degrees. Both of them are 2's. So we know that n is equal to m. So we are going to have a horizontal asymptote. And this one we find by doing y is equal to a over b. Both of them were 1s. We had a 1 in front of the x, 1 in front of the x. So 1 over 1, which is just equal to 1. So when y equals 1. And that's our horizontal asymptote. So we have our vertical, horizontal. We want to see if there are any holes. The numerator we saw could have zeros at 2 and negative 2, the denominator at 0 and 4. There was no overlap, so there are not going to be any holes. So let's just get a few more points for graphing. So once again, these would just be numbers that you pick. We want 3 in each section. The sections are determined by those vertical asymptotes. So we got over here on the left, we got here in the middle, and over here on the right. And we only have 2 dots. So let's go ahead and get some more. So at negative 10, if I put negative 10 in that equation, I'll get approximately 0.7, negative 6, 0.5, negative 1, 0.6, 1, 1, 3, negative 1.6, 5, is that a 4.2, 7 at a 2.1, and 10 at a 1.6. We've got our points. We can now start putting them onto that graph. So at negative 10, we should be up just a little bit. At a 0.7, at negative 6, just about halfway up to the 1. Then at negative 1, we should be down at a, oh sorry, that should have been negative 0.6. All right, and so from there we see it's coming and then it just started going down. Here in the middle, at 1, we should be at 1. At 3, we'd be at negative 1.6. So we can see it was rising up, so it's going to come up and get closer to that asymptote, and then down here it'll do the same. Now at 5, we were at 4.2. At 7, 2.1. And at 10, 1.6. So using that as our guide, there would be our graph. Okay, one final problem left. And once again, the first thing we want to do is to factor the top of this. So, well, factor both of them. The top one, because it's an x cubed, that looks like it might be a little bit more challenging. So I'm going to start off trying to do my factor by grouping. So I can take out an x squared from the first two, and I'd have x minus 2. I could take out a negative 1, and then that would show as x minus 2. Since both of those now have a factor of x minus 2, I can now write that as x squared minus 1. X squared minus 1 is a difference of squares. So we have x minus 2 times x minus 1 times x plus 1. All right, so I factored my numerator to x minus 2, x minus 1, x plus 1. The bottom is also a difference of squares that would separate into x minus 2 and then x plus 2. So something very important to see right here. Notice we finally have that situation where the numerator and the denominator are going to equal 0 in the same place. So rather than waiting till later, I'm just going to state it right now. We are going to have a hole where x is equal to 2. Now we may also want to figure out what the y value would be there, but that'll make more sense after we start to graph it. Essentially what we would do is we ignore that part of the equation and then just substitute in x equals 2 and find out what we have there. But we'll cover that in just a moment. Let's go ahead and get started into our normal stuff. So the x-intercept. Now we already know that the minus 2, that kind of cancels out of both of them and becomes the whole. So I don't need to focus so much in on that. Right now, I just need to know when the numerator, the rest of the numerator would equal 0. So the x minus 1 and the x plus a 1, when those will equal 0, and that's going to be when x is equal to a 1 and when x equals a negative 1. So those are going to form my two x-intercepts, essentially 1, 0. So when x is 1, the equation is 0. When x is a negative 1, it equals a 0. And we've got those graphed. Next, let's move on to the y-intercept. So the y-intercept is going to be when all of those x's are then turned into zeros. So let's just look at that. And so 0 minus 1, 0 plus 1, all over 0 plus 2. So we're going to get a negative 1 times a positive 1, which will be a negative 1, all over 2. Okay, so when x is a 0, y is a negative 1/2. And there's our y-intercept. Okay, so after that, let's start looking at our asymptotes. So the vertical asymptote is where our denominator is going to equal 0. And we already eliminated the x minus 2, so just the x plus 2. So when x plus 2 is equal to 0, that's when x is equal to negative 2. So there's our vertical asymptote. We'll be at negative 2. Okay, and now let's also talk about degree here. The degree of the top is greater, so the degree of the numerator is greater than the degree of the denominator, and that means a slant. So we are going to have a slant asymptote now. Slant asymptote is going to require us to do some simplification of this up top, and then we'll do some division. So I'm just going to remultiply those two out, and we would get x squared minus 1 all over an x plus a 2. And I'm going to go ahead and use synthetic division. So negative 2, 1. Notice, so the 1 for the x squared, there is no x here, so we put in a 0. And then negative 1. So 1, negative 2, positive 4, and then we would get 3. Now, I don't care about my remainder here. Remember, slant only cares about the equation without the remainder. So that's a 1x minus a 2. So my slant equation is where y is equal to x minus a 2. Now that's a normal line. So let's go ahead and put that in. We know the y-intercept of that would be at negative 2, and then it goes up 1, forward 1, up 1, forward 1. All right, so this right here is my slant asymptote. It's just graphing the line y is equal to x minus 2. Now, right now, let's also get a bit more specific about where that hole is going to be. So we know it's when x is equal to 2. So let's use what remains of this equation. 2 minus 1, 2 plus 1, all over 2 plus 2. So we'd have 1 times 3. So it'll be when x is 2 and y is 3/4. All right, so I do know that right here I'm going to draw a special dot there. It's going to be an empty dot. That is our hole. So for this part of the graph, we can see the shape pretty well, especially given our hole that we got right there at the 3/4. And then that's going to keep on getting closer to that asymptote. So now I need some that are down here. So we could start finding some points. We've done that enough. Essentially, we're going to get a line that looks like that. I don't want to make this video any longer. And there we go. There's our graphing with the slant asymptote.